Good morning, ladies and gentlemen. I would like to say thank you for coming in our presentation. Please allow our scientific research team, consisting of me, Anissa Salsabila Genomti, accompanied by two of my colleagues, Abdurrahim Alhiwan and Dimas Dikunchoro, assisted by Muhammad Nur Ihsanuddin, supervised by Professor Dr. Engineer Agus Purwanto, from 11 Smart University to present the result of our research with the title Fuel Modification for Anode-Free Lithium-Ion Battery from Electronic Cable Waste. As we know that energy has become one of the important aspects to help daily activities. Human mobility currently depends on digital and portable items that can be used using energy stored in energy storage device. Battery is currently the most efficient source of energy for use in the mobility of human life. Currently, battery with lithium ion are one of the battery used. Therefore, the development of lithium-ion battery continues to be carried out to get better performance. In lithium-ion battery, there are several problems caused by anode, namely its high electrochemical reactivity. To overcome this, there are new innovation with using of anode-free battery. Basically, the working mechanism of this battery is the same with the previous lithium battery, but the anode used in this is smaller in capacity, so it can reduce the volume or large on the battery. Anode-free batteries have caught great attention for their implementation in the development of lithium-ion battery. This is because it has proven that there is a significant cost reduction as well as simpler manufacturing procedure with the absence of anode. Several research have designed a continuating of the more practical anode-free rechargeable lithium battery. However, there is a problem named the uncontrolled growth of dendrite. The growth of dendrite can interfere with the running mechanism of the battery, so it's necessary to evaluate its growth. The way that can be done to overcome this is to modify the Cu file in the battery by adding Cu on it or copper on it. Several research have proven that one of that is conducted by Yai Wang et al. In 2019 that modify copper oxide by adding nano-Cu particle to maximize the capacity and cycle of this battery. Cu is obtained by electronic cable waste. Cable are one of the objects that are widely used in everyday life. But unfortunately, the processing of waste of cable is not done properly. Data shows that the electronic waste generated by Indonesian population in 2016 was 1.274 million tons. Electronic waste is included in P3 waste, which is dangerous when not processed well. The Central BPS or Badan Pusat Statistik said that P3 waste from surface infrastructure, including electronic waste, is in 2017 reached 6.03%. With the increase in unused vehicle and other e-waste around the world, making the amount of waste electrical wires a significant problem in terms of environmental protection and recycling of resources. The step is using Cu from cable waste is considered effective for increasing the use value of cable waste as well as improving anode-free batteries so that the development of lithium battery is getting better.
The first process of the research is now how to make copper oxide material from used copper cables. Now how to make lithium-ion batteries. Now the performance of the lithium-ion battery with modified copper foil. Method is preparation material, manufacturing powder, modification foil, characterization material, photometry, electrochemical impedance spectroscopy, X-ray diffraction, human battery analyzer, scanning electron microscopy, X-channel battery analyzer. The collecting data is with the analysis instrumental and research operator. The first mixing stage, 5 ml of concentrate sulfuric acid was put into a baker glass and continued with the addition of 20 ml of distilled water while stirring slowly. Then a piece of copper weighing in is put into the stirred solution. Then nitric acid was added and stirred until the brown gas is clear. The result of mixing one were filtered and the filtered was stored at room temperature. And the crystal form is copper sulfate pentahydrate. And in the mix two, we added oxalic acid with the concentration 0.0125 molar. The precursor solution was made alkaline by adding oxalic acid to form salad. With the process heating and centrifuging and then drying, then form copper oxalate. Then we reduct the copper oxalate with graphite oxide. The resulting solution is the result of drying the oxalate in graphite oxide with the ratio 1 per 0.1, then sintered in the furnace to a temperature of 800 degrees Celsius with a heating rate 12 degrees Celsius per minute and isothermal temperature for 30 minutes produce copper powder. Then the tests were carried out in the form of scanning electron microscope and X-ray diffraction for characterization of material. So powder from electronic cable walls is mixed with PVDF, polyvinyl difluoride solution, and then made a slurry in mortar. And with AB, acetylene black. Furthermore, the slurry and silver are combined through the coating stage to form a layer. Furthermore, the coating results in an oven at a temperature of 70 degrees Celsius for 12 hours. The commercial LNMC cathode material that has been prepared is added with AB and PVDF until everything is homogeneously mixed, and then NMP is added until it is mixed into a cathode paste. Subsequently, the cathode paste was coated in the aluminum foil sheet using an automatic film coater. And before we coated CO foil, we added NMP2 with the AB, PVDF, and CO powder. It's the same process with the coating aluminum foil. The dried battery film and material will be processed to form a cylinder cell battery. Battery film is pressed using a hot rolling machine and molded into a round shape. Cylinder cells were made by cutting the dried battery film with a size of 10.5.6 centimeter, 10 long and 5.6 centimeter as cathode film, while the film material was cut with a size of 13 centimeters. After that, the battery component plates are rolled together with the separator based on the separator and not separator method arrangement. The cylinder cell battery is arranged into the glove box by adding an electrolyte solution to the cylinder cell. Furthermore, a full cell test was carried out on the battery using an external battery analyzer to determine the performance and capacity of the commercial aluminum battery and not free lithium-ion battery that had been made.
The result of the test sample showed that there was copper oxalate with an average size of 415 nanometers. In the journal Chauhan et al. 2016 mentioned the copper particle size is 70 to 400 nanometers with a magnification of 120,000. The difference in the value of the particle size is influenced by the process temperature, and the resulting stress will also be different. In the EDX test result, the peak copper oxalate is 8 kilo electron volt. In the journal Chauhan et al. 2016, the peak value is 8.9 kilo electron volt. The difference in value is due to the surface size of the analyzed particle. The larger the surface area of analyzed particle, the more extensive the stress testing of the copper particle will be. This allows for an increase in the analyzed stress quote from Zheng et al. 2007. After calculating linear regression on the copper oxide nanoparticle synthesized sample in the journal, the value of A equal 0.4668789 Armstrong and C equal 0.511844 Armstrong, and the lattice parameter C per A the test value obtained A equal 4.048969646 Armstrong and C equal 4.6405172704 Armstrong, and the value of the lattice parameter is 1.146098293 Armstrong. This shows that the layer structure material formed from the sample is fully compatible and systematic because it has parameter value that are closest to the copper oxide spherical structure. In the result of the anode-free battery performance test, the result of a cycle compression were obtained where the specific capacity of the anode-free lithium battery NCU modified AFLB at discharge was 100 cycle with a copper modified AFLB capacity of 123 milliampere hours per gram. While in AFLB it is only 50 milliampere hours per gram. In Wang et al. 2016 study using CO oxide polypyrrole, the specific capacity was 401 milliampere hours per gram with 500 cycle. Therefore, further study are needed on the efficiency of increasing the specific capacity of CO modified AFLB batteries in order to obtain more optimal results. Sudah selesai.
This is our final presentation of the result of research foil modification. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.
Yang stop siapa?